Good evening, everybody. Welcome to Triangle Area SQL Server User Group Data Science Edition. So we are on the 4th Tuesday of August. Kind of moved back just a little bit. But we are glad to be able to host tonight Bryan Shalloway, who's going to talk to us about our interface for analysis and databases. So please, Bryan, take it away.
Thank you. So today, my talk is R's interface for analysis databases. My background is I'm a data scientist at NetApp, and if you want to connect with me after the talk, you can do either through Twitter or GitHub at @BrShallow, or connect me on LinkedIn, or I also will post blogs here at bryanshalloway.com. Just a little bit about my background. So I'm a former high school math teacher, and then was in analyst in education after that, and then I've got my master's in advanced analytics from NC State, and I've been a data scientist at NetApp since 2017 in the customer support and sales spaces. So worked on problems like ranking incoming support cases, doing forecasting for our sales across our different products and geos, and doing pricing optimization problems in those spaces. I'm also very much an RStats, I'd say, junkie and open source enthusiast. I want to just be clear that although I'll be talking about R and translating into SQL and databases, I'm not an enterprise architect, database administrator, or any of those things. So for those of you that are, please go easy on me in those areas in the question section at the end. Just something fun I wanted to show off for that. I feel like maybe March, April was more the time when people were working on hobbies. But this was me last week. I finally got up to juggling 4 balls, so just something fun to share, a new achievement for me. It took me a lot longer than you would guess just to get that few second clip, but I'm very proud of it. So I thought this was a good opportunity to show that off. So today what I'll be talking about again is translating R, and really it's about translating dplyr code specifically into SQL. So dplyr is a package within R that makes that all of this typically will run on. So I'm not going to go into the details of all of this right now, but typically, so this is an example of dplyr code. So here we have empty, this is pretend some table. We're saying group by cylinders, and then we have some summarize the values, and then we arrange it. And then you can also do this, take this, and then translate that directly into SQL, and then run this on the database. So this is what this talk's going to be about. I'm going to give a more full example here. I just wanted to frame it. Everything will be kind of centered around this, with different examples and different places where this can run. So why would this be valuable? And this is kind of, I was thinking about if you were somebody who was more on the database administration side, why would this be valuable? I think one is that it can make analysts more efficient. Either somebody who knows R already well, and they now have a way of running this on the database. And then also there's certain queries that SQL can become really a lot harder to write with, that become easier to write in R or with some of the packages that I'll be describing. So that's one reason, is just to become more efficient. And then I also think it gives a minimal setup for supporting analysts who want to deploy R code or models in production environments, because basically all you're doing is just having to run SQL, which rather than having to get a whole some other environment set up. So those are 2, I think, good reasons why this could be useful. So this first part of my talk is going to be going through kind of some just common parts of data science and an overview of R. And then the second part of that will be going through some examples of where this can be run on the database and how. But first, I just want to kind of give the motivating principle around some of the background of the growth of R and Python and scripting languages for data science in general. So here's a common diagram. Pulling data in where you're having to transform it, and then you may have some visualization you're doing, and then you may want to build some model off of those, and then you're communicating these pieces. And also the circles are going all around, because there's this iterative process where you're you're exploring different pieces and having this kind of the whole time you're communicating with the individuals or with different systems. And there's this iterative process, and there's a lot of different pieces to it. So if you think about, I think historically, each of these steps was maybe handled more by modular tools. So you might think you would pull data in something like SQL or Alteryx or Power Query. You could then use business intelligence tools for doing visualizations on those. And then you might use, statistical or modeling tools for building models from these. And then you might use Word, Adobe, or other systems for actually then building a report or communicating this out in some way. So I think this is kind of like, so these are some historical tools that where this happens. Oh, and then I mentioned programming. Then you may write macros or functions or use other programming languages for this. I think, though, that there's been a shift towards doing all of these things together. If you look at any of these individual tools, they've expanded their scope a lot. Like if you think about Tableau, for example, you've got like the whole Tableau prep that's become their big focus, where they're now trying to get into this whole, be able to do all the transformations within Tableau. If you look at any of those individual tools, I think they've really, tried to start doing more of these different pieces. And I think that really, though, this has been where our Python and just scripting-based approaches in general really excel, is that you can do all of these different steps in one individual tool, or you can do many of them in an individual tool, and that doing this reduces some cognitive load. So that's, I think, one advantage. Another advantage is that the facilitates more flexible operations that you can do generally by doing this in a scripting package. And I think also that you have had modular packages rather than modular tools kind of take shape. So here's just an example of some different R packages that exist for each of these steps. So these are all within R, but these all have a consistent flow that go with them, but you have these modular pieces that can handle each of these different parts. But it's all, you can do it all within one language, at least if you're focused on specifically on data analysis. So now I wanted to go through an example of this tidyverse style code, and how, what I really like about this is that it makes all of these parts really consistent. They all have a consistent style with them. That's, I think, one of my favorite things about coding with R. So it gives us highly expressive, intuitive language for doing all of these common steps for any kind of data analysis tasks. So before I go into that example, I want to just go over a few quick things about R in case you haven't seen the language, just to know. One is that this less than minus sign represents the assignment operator. So you could also use an equal sign, but this represents an assignment operator here. Another thing to know is that dots in R don't necessarily mean anything special. They're just like any other character. There's some conventions around how they're used, but they don't actually represent anything. They don't necessarily represent anything. Also, these percent, greater than percent signs, these represent R's pipes, and these can be interpreted as kind of like and then statements, and then do this next operation. So like in this case, we're saying, here's this iris data set, and then let's drop this column sepal.length, and then let's mutate all the columns that are numeric and do a log transform on them. That's kind of how this can be read. So you're kind of moving along this piped operation. And then one other note is that if you're doing visualization, so using ggplot, rather than it being the pipe being this percent greater than percent sign, it is the plus operator. So just when you see plus and it's a visualization, these basically mean the same thing. They're both representing and then statements. So I want to go through just one quick example that I think showcases how with R, you have each of these different parts can have a really consistent style to them. So whether you're doing transformations or visualizations or modeling, there's a really consistent kind of approach to it. The example I'm going through is not a full example. There's some other packages that do this in a much more robust way that I'm not going to go through here, but I think it just kind of shows how this consistent style is applied really briefly in across different operations. Okay, so here we're starting with the Gapminder data set. Okay, so we're saying start here. Here's our data set. And what I'll be doing too is I'm going to go line by line. Just pretend that there's like a print statement after each of these. So on the right-hand side, I'll just be printing out what the output would be if I were to cut it off right then. But this is a way of just showing it kind of building out. So we're starting with this Gapminder data set, which has information on different countries and then the life expectancy and some other variables. So then we're saying, okay, let's drop the variables that we're not caring about for this example. Then we're going to group by country and continent. And then we're going to nest by that data set. So now what we actually have is each row represents an individual country within a continent. And then we have a data frame of our values within that individual row now. So we've got life expectancy in year actually built out observations within each row here. And then within that, we're actually going to build a linear model on each of these data sets. So now we're building a linear model for each country that is here. And then we're taking the results from those. So we're glancing at the results. So that's what this step is doing. So now each row we have a linear model. We have the results from that linear model. And then next we will just unnest and extract those results. So now each row we have an individual country, individual continent, and then we have some measures associated with the performance of our model. So essentially, how much can life expectancy be explained by the year? And then, so here what we did was we did some transformations, we did some modeling, and then now we're going to go into visualization. You'll see that there's this still consistent kind of like flow. So we'll put this into a plot. Right now we haven't actually specified anything, but we'll say, okay, our x-axis will be continent, y-axis will be our squared metric. We'll make this a box plot. So now what we have is we can see, okay, here's the range for each of our countries. Here's the range of some performance metric by each continent. So we can see, okay, it looks like for Africa, there's a much greater range in how much year explains life expectancy for countries within Africa compared to the other continents. And then here, I'm just going to overlay each of the individual countries on this box plot. I'll add a color based off continent, and then add some labels, change the theme. So this just kind of, I think, gives an example of how the pipe kind of facilitates this nice flow to operations when you're doing data science type things in R. And then here's just some more formatting things. So that's one of the things I really like about R, is that it has this kind of suite of tools that make all of those common data science operations really, really smooth and clean and consistent with one another. And this is particularly in the tidyverse, which has grown a ton in the last, say, 5 years or so. Now, there's also some challenges with R. It's a niche language. I want to talk about how it kind of handles those. So one is that it may not be the ideal compute environment. You may not. You may want to use some larger compute environment. That's one thing that you may not want to use for. Second is that the technology has a relatively, as I said, it's a relatively niche language. Although it has a lot of users, it doesn't have as many users as some of the bigger languages. So a technology provider may not immediately create an API so that R can interact with it directly. So to understand how R kind of handles this, or how some of the main package developers handle this, it's helpful to know a little about the history of R. So R's precursor S was actually written as an interface to Fortran for use by statisticians. So because of this, the way it's written is it works really well as an interface, and it's really easy to create interfaces into other languages or other systems. So there's some really great packages. So Reticulate's a package that allows you to run Python processes directly within R. RCPP, curl, there's some packages for running Stan. There's a bunch of other languages that you can actually then use R as an interface to running those pieces. So it gives this kind of like high-level language that's optimized for statistical analysis. And then if you need things from other places, you can run those directly through R, or you can interface with them in some way. And it has a lot of really well built out ways of doing this. And today, what I'm going to be focused on is how it can serve as an interface when on SQL. So that's kind of the focus of today. So I'll start with just this quote. We want data scientists to live in a world where technology is hidden from them, where you can use the R packages you know and love, and they just work. And this is pulled from a book called The R in Spark, which is publicly available online. If you just Google the R in Spark, you can read it. And it kind of gets at this notion that the goal of a lot of these package developers is to make a really smooth, clean interface that is consistent with the tools you're used to working on, and that can perform all these different operations. And that the idea then is that you can take maybe let's say you want to take advantage of the SQL engine or compute power or whatever technology you want to interact with. The idea is that you can use these things in those environments as smoothly as possible. So rather than thinking of, I think traditionally our users maybe have just seen SQL something that they use for importing their data. The goal of this talk will be to give some examples of how you can expand your use of the SQL engine so that you can actually you can use the packages you like, use the language you like, but then run some of these operations within on the SQL engine itself, so that you're not, so you can take advantage of some of those compute issues with just running a local session. I also want to give credit to Edgar Ruiz from our studio. All the slides from here on out are either pulled from presentations that he's done, or I copy and pasted snippets from different examples that he's put together from different packages he maintains or websites he maintains related to some of the packages that I'll be going through. So with that, I'm going to start with just like a traditional situation as an analyst or as an R user, just to paint a picture of kind of a common challenge that may exist. So currently, you may have your local R environment. There may be some SQL database that you're connecting to, but there's kind of a small conduit here, and it's costly to like pull all the information over. But there's a few approaches that I think traditionally people maybe have used. One is to save small pieces of information over and then analyze that information later. So if you write pieces and then analyze that later, or maybe to load a lot of data into memory directly and then work from that. But neither of these approaches are actually taking advantage of the SQL engine on the database itself. So that's what I'll be talking about, is how you can take advantage of that. And I also just want to have just a little side note that outside of this talk, it's a very reasonable approach just to take a sample from, in a lot of instances, just taking a sample from the database or from some larger table is completely reasonable, makes sense. And if that is fine for your problem, then do that. I think that's an underused approach, just taking a sample from your data and can make problems easy and quick to solve in a lot of instances. So I'm not going to talk about that. Just wanted to have a shout out that sampling is a great approach that I think is often underutilized. Okay, so ideally though, we'd like to analyze our data in place on the database. So let's say we have this question of what are the total sales by month? Okay, so we've had established ways of just running this as a SQL statement on the database, but as these questions become more, and then returning the results directly back in R, but as these questions become a little bit more sophisticated, these SQL statements can get more complicated, and as you have, I think, more sophisticated questions that data scientists start to answer, or start to ask, this can become, can create increasingly complicated SQL statements. So the goal then would be to be able to use R code, or specifically dplyr code, to run on the database. And that's basically what we'll be talking about. So in this case, this is what we're doing is this is the equivalent dplyr statement. And what this actually happens is the dplyr writes the SQL query directly. So you write the SQL code, and then this, if you said show query, this translates into SQL code that actually gets run on the database itself. And then after having run this on the database, then you just return whatever small amount of data represents the final records. So the whole goal of this is really just pushing the compute to the database, while still being able to use our piped code that's modular and easy to read that we like. So in terms of the pieces that make this possible, so the three core packages are odbc, dbi, and dplyr. So just the first step with this typically is to establish a connection. So here what we're doing is, in terms of like the responsibilities of each of these, so odbc typically is what's actually handling say the drivers. So usually you'll need to install the driver, and then you'll specify that it's an odbc driver. And then dbi then, which represents database interface, is the thing that you'll actually call to create the connection, and that actually will end up sending the SQL statements that you're generating to the database. So this actually is what's running it. What dplyr is doing is essentially allowing you to, it's actually is translating the actual SQL code that then dbi is actually sending. So dplyr is what you're actually writing in, creating the operations in, and then that gets sent to the database via the dbi package. So that's how these ones interact with each other. There's a lot of different databases that are supported currently. So here's a list of different databases that are supported. And the one little bonus advantage too, I think, of using this approach is that the different dialects of SQL between these different database systems are automatically handled here. So you're just basically, if you're coding in dplyr, and then depending on what the connection string that is specified is, it will do whatever, it'll translate into whichever dialect it's connected to. So that's, I think, one little bonus that you have to keep in mind, the little subtle differences sometimes between SQL dialects. So I'll just give an example. First, just using DPI. So as I mentioned, DBI is, I think, actually sending the query statements. So here, we're loading our packages, so you can pretty much ignore these. These are just loading the packages that we need. And in future examples I'll give, I'm actually not going to show these loading these library statements in, but in this example I did. I'm creating this con object, which just represents our connection. Typically, you'll have probably more fields that you need to enter here, but we're just establishing our connection to the database. And then here, to do dbGetQuery, we're specifying our connection, and then this is then just our SQL code itself, just quoted. So this is just using dbGetQuery. But we could do the same thing, as I said, using dplyr. So this is that equivalent statement, now just using dplyr. So here we're just specifying, okay, the bank table is what we're using. We're doing a group by and then summarize step operation. So if I just go back to these are, notice the same, these are the same statements. This is just using SQL to do it, and then this is then using dplyr. So then this is what actually gets pushed to the database and is actually run there. And when this actually, I don't actually have this here, but if once you do collect on this is when actually this thing actually gets run and then pulls in whatever the results are locally. I'll have an example next that shows that. And a nifty thing too is that you can do show query if you're to see exactly what the SQL code this is being translated into looks like. This is cut off here, but it looks the same as was here anyways. You can write the code in dplyr and then say show query to see what's actually being run on what's actually going to be sent. So next, I'm going to go through some best practices in a few different spaces. So first, I'll be talking about visualization, and then I'll be talking about modeling frameworks. And these are just going to go through a few different things to know, and also some packages that kind of make some of this easier. In all of these cases, though, what these things are actually running on is generally dplyr. So some of the modeling packages that I'll be going through, the packages themselves are, creating model functions, but they're actually in the back end, they're generally creating these by taking advantage of dplyr doing this translation service.
Bryan, we have a couple of questions that came up. Good questions for you.
Okay.
First, would you like to have me wait until you get to a stopping point?
No, that's fine. Now's fine. I'll jump into these examples in a second.
Okay. So the first one goes back to the discussion of interfaces like Reticulate, RCPP. And the question is, does interface just mean you can use other language functions?
Yeah, so in the case, they can mean a little different things depending on, so I wouldn't say that they're all completely uniform. There can be differences, but for example, with Python, Reticulate means that you can load in any function and then run it from R. So that's the way Reticulate works. So just a little bit of background about like the creation of Reticulate. Basically, the makers of it, they were first working on getting TensorFlow to make that usable within R, and so they were trying to get Python's TensorFlow package to be usable within R, and they needed a way of creating that interface, and they did such a good job with it that then they released Reticulate, which allowed it to basically work general purpose across Python packages. So yeah, essentially it lets you run any Python function within R. And then there's also, I think, RPy2 on the other side for running R processes within Python. But this can kind of vary depending on, I was kind of a little bit vague there. So it can mean a little bit different things, but that's what it means in the context of Reticulate.
Okay, great. The other question relates to use of dplyr or dbplyr, and also other possible ways of querying data, like straight from DBI with dbGetQuery. What would the performance differences look like?
Between using dplyr and just DBI directly, there shouldn't really be much of a performance difference, because dplyr is just basically creating the SQL statements that get run. So whether you're just doing the query with SQL directly or via dplyr, there shouldn't really be a big overhead. It's just going to be in terms of generating the SQL statements, because it's actually running SQL. It's just generating the statements.
Okay. All right.
So there shouldn't be a huge difference, because it's SQL is what's actually being run. Yeah.
Right. One thing that we do sometimes run into with say like translation libraries, something like Entity Framework in .NET, where it'll take C# code and create SQL from it, is that there can be some interesting ways that it translates the C# code to SQL, and that can lead to some performance problems.
So I would say that has been improved somewhat up to this point. So like I think if you looked at the translate query, so like let's say you generate, you make some dplyr code and you look at the translate query. If you look at that now compared to say 2 years ago, it looks a lot cleaner now. So I think a lot of that has been improved. So this has been improved a lot, I think, the last couple of years, where those translations look a lot smoother than they did previously. And I think, yeah.
Very cool. Thank you. That was all the questions for now, and I'll.
The details of like why R serves as a helpful interface language. There's advanced R programming though gets into this a lot about how R's abstract syntax tree works and how it handles creating expressions that makes it such a flexible interface. So if you're interested, I recommend the book Advanced R Programming by Hadley Wickham that gets in a lot more detail. So as I said, so I'm going to go through the next few examples are going to be, so I went through this initial example of dplyr. I'm now going to talk about visualizations, and I'm just going to go through basically a few different packages that kind of give helpers for doing this. And as I said, most of this is actually in the backend being run on dplyr, but just some packages that kind of like make this easier. So okay, so let's say you're doing visualizations. If you are doing this on a database data, what you want to do is you want to do any aggregations associated with your plot on the server side, and then just basically load in the summaries that are what you actually want to end up plotting. So just to give an example of this, in this case, we're getting counts, flight counts based off of origin. So here we're actually running this first on the SQL and we're first running this in SQL, and then as I mentioned, whenever you have this collect statement, this is when we actually pull it in locally. So this is when you see collect, that means it's actually being executed, and now we're going to pull the results in locally. So here we're just collecting though what actually gets sent to us across that. What's actually going to have to be sent locally is just these 3 rows. So it's a lot less data that's being transmitted over. And then once you have that, that's then what you can actually plot. So now we're feeding this into some visualization. Just to show equivalent code, you could also do this just in one single pipe. This is the same thing. We're just not saving an intermediate object. So here we're specifying the flights data set. And just as a FYI, there's also an in schema function. So let's pretend that you have multiple you've got multiple flights tables. In schema can let you be a little bit more specific that will wrap around this, but I'm not showing that in this case. So we're doing this operation, we're collecting it. So now this has been pulled in locally, and then we feed into visualization. So these are both the same thing. In just one case, we saved an intermediate object, and the other we did not. There's some visualizations, though, that are not maybe as simple to just pull all the data in. So let's say we're building histograms or doing raster plots, things like that. There's this package called dbplyr that basically gives some helper functions for this. So in this case, when we're building a histogram, so we want to look at, here we're looking at the distance variable, and we want to see, okay, what's the distribution of the distances of flights within this data look like? In this case, you're having to figure out what are the ideal bin widths, all those pieces. dbplyr is just a package that makes some of these visualizations that require some calculations. It's just basically gives some shortcuts for doing those. You could also just use dplyr to calculate these and then just pull in these bars that way, but this just makes that easier. So now I just want to talk about a couple of packages that for correlations and modeling that are, again, kind of like helper packages. So there's the core package that has this correlate function that you can run on a table, and what it returns is essentially each individual cell represents the correlation between 2 variables. So determined based off of the row and column that it falls in, it'll specify the correlation between those variables. And then you have some other helper functions that allow you to reshape this this returned output. And again, this is facilitated based off of dplyr actually being the thing in the backend that's running this, that it gets converted into SQL and actually runs this on the database. So in a similar manner. So just as an example, here we're specifying, again, I'm just using SQLite database here. Or as I said, I pulled these examples from Edgar. But here we're just running the correlate function across all the different variables here, and then pulling that in and plotting them. So here we have then this plot of all of our correlations. So just looking at one example of this, so you can see miles per gallon and cylinder have a negative correlation. So in other words, the higher the miles per gallon for cars, typically the smaller the cylinder size of the engine. That's what this is showing. But this is another package that again you can calculate these correlations on the database directly. Another really cool package is TidyPredict. So the steps for this are a little different. It's not, in this case, you're actually not doing everything on the database. In this case, what you're doing is, let's say you fit some model locally. What this will do then is parse the model, translate into formula, and then dplyr turns this into the, and then dplyr actually turns that into the SQL statement that gets run on the database. So in this case, you're actually building the model locally, and this gets parsed into the SQL statement. One cool thing about this too is that it can get saved as a YAML object. So what this actually means is that you can build models not just in R, you can build a Python model. If you save it in this YAML object, you can actually then have TidyPredict call that model that was created in Python and then build the SQL statement for getting predictions based off of that. So then after you've built the model, just a quick example of what this ends up producing, you might set some table where it'll be, you're updating, you're scoring incoming cases based off of, this is an example of a linear model. So you're just, here represent all of your coefficients. If this was using a more sophisticated model type like XGBoost, this SQL statement would be way, way, way longer. In the references, they have an example where they use an XGBoost model, and that you can see there's a much longer SQL statement. So here are the current models that are supported by this package. So you, again, this is a way of basically generating SQL statements that will produce predictions for some model that you built locally. Now, in terms of actually building the model on the database directly, there's a package ModelDB that, again, allows you to actually build the model on the database side. And you can actually use this thing then in conjunction with TidyPredict. Again, in the references, I have something that goes through ModelDB a little bit. It goes through an example of ModelDB. ModelDB isn't quite as mature as TidyPredict. There's only a few models that are supported by it right now. But I think it's still a cool setup. And again, a lot of these have really been developed in the last few years. So they're building this ecosystem out a lot. So I'm really excited about kind of just like the expanded functionality that's going across all of these. And again, in the references is a more full example of this. So a few just important notes that I didn't cover. So one is that just to reiterate, not all of R is supported. Mostly it's just dplyr or things that can run on dplyr, which is still a lot. Another thing that's I think helpful to know is that SQL functions that don't exist in R can also still be run. So if there's a function that's specifically you just basically put it into your dplyr verbs. If it's not recognized within R, it will check to see if it's a SQL function and run it that way. So you can still use SQL functions within this workflow. So it can be this kind of mix. And again, so db.rstudio.com is where there's descriptions of best practices around interacting with databases. And also it has details on things like security and a bunch of other topics that it didn't actually cover. And then there's a lot of other relevant or really important packages that use this similar framework. So sparklyr is one that, again, it's in this case, you're using dplyr to run on the Spark engine, but this actually also takes advantage of some of the machine learning libraries within Spark, as well as setting up production pipelines and things like that. Our sparkling is enabling for H2O within Spark. DM is a package for doing more like database administration type work through R. So let's say you're setting keys, things like that. This is DM's more for database administration type tasks. tidyquery is then kind of going the opposite direction. So I talked a lot about here's this dplyr code, let's convert that into SQL. Tidyquery goes in the opposite direction. So let's say you have some SQL code and you want to convert that to dplyr. It's set up to enable that. Our JDBC is it's rather than using odbc connections, you can use JDBC connections and still use this whole dbplyr interface. ODBC is just kind of like most of the examples are set up through that, but just to note that our JDBC also works. And there's a lot of other packages that people have built that kind of like build off of these things. These are just some of the big ones that I didn't cover. So yeah, here are some of the key references, and then again, my information. But that's all I have. So time for questions.
Great. So if there are any questions, please feel free to drop them in chat. I will intercept the first question that I expect will be asked, which is, will you be able to make available the slides?
Yes, I'll post these on GitHub sometime in the next couple days.
Perfect.
I'll post on the meetup group just a comment there once I posted them.
Yeah, that's exactly what I would have done. So yes, please do.
Cool. Yeah.
So you mentioned DM that you didn't get into very much, but I was wondering, you said it was database administrative.
Yes, and I don't know a ton about it, to be honest. It's relatively new, so I didn't talk about it because I also haven't used it a ton. I've gone through a few of the examples, but it's basically set up to so you can create a data model from within R, or you can extract a data model that exists within a system. It's kind of for pulling some of those metadata type pieces or setting those up from whatever database exists. It's specialized for that. But I honestly don't. I haven't really used it other than going through a few of the basic tutorials. So I can't speak that much to it.
Okay. So there is a question here. I'm not sure what TidyPredict does. Does it fit models or does it simply score models?
TidyPredict scores models. So TidyPredict scores models. ModelDB fits models. So what you do is essentially you fit the model. You can fit the model locally or using ModelDB, and then that fitted model. It's a way of translating that fitted model so that you can then score things on the database. So that's what it's set up to do.
Okay, cool. Next question. How difficult have you found it to use ODBC? Have you tried it at work where connection restrictions might be greater?
I would say for me, the most annoying part almost universally is getting the initial connection string set up and figuring out, that's universally where I sometimes bump into issues. Otherwise, I found it pretty smooth for the most part. I think, especially for simple things. If you're doing relatively simple operations, but for the most part I found it pretty smooth, with the caveat being that I usually struggle with getting the connection string set up. And I'd say too that initially on some systems I found it to be a little bit more smooth than others. I had a problem I was working on where it was a mix of SQL Server databases and MySQL databases that I was pulling from, and almost any operation I ran I felt on the MySQL database I didn't run into issues, but sometimes on the SQL Server databases I did run into issues. But this example I'm thinking of is kind of when it was first coming out, and I think some of those issues have become a little easier, as I said, as it's gone through more development over the last few years. So for the most part, pretty smooth.
Okay.
And then when I do run into issues, then that's just a situation where you can use, kind of debug what the dplyr is translating to see where there might be an issue. So that can be really helpful too, or just sending a SQL query in directly if it's really not working.
Okay. Is there a way to take the query and figure out what is the translated SQL code without using a tool like extended events and SQL Server to try to pull?
Yes, they have. I should remember the function, but they have basically you can simulate. You can do simulate this database. So you could do like simulate Postgres, simulate MySQL. You could like simulate the database, and then you create, say, like a table that hypothetically exists in that environment, and then you can simulate the SQL from that. Yeah, so you don't actually have to have it existing there. You can simulate that environment and then what the query would be.
Okay, great. Your first few minutes were the best introduction to R that I've ever seen.
Thank you.
Nice. There's a suggestion of using the format of package : function so that it's clear which package individual functions are coming from, especially because you are running through a lot of different packages.
Yes, I'll try in the maybe I'll add to the notes on like a little bit more explicitly there. Here I was trying to make, yeah, I think that's good feedback. There's always that balance between wanting it to be as little that you're looking at versus being as explicit as possible in a presentation like this. But I'll add to the note section and make that more explicit so that you can see what the library statements were and things like that I just completely skipped in many cases. But yeah, thanks for the feedback.
Yeah. Let's see. Anybody else have any questions or comments for Bryan this evening? Mike did like that I dropped a link to connectionstrings.com, which has generally been my go-to for, I have no idea how to connect to this database. Give me a string, please.
Yeah, yes, that's helpful. Yeah, I've definitely had a few when like I just get completely overwhelmed and I'll send out some tweet to be like, does anybody, and then somebody else, it's helpful to have a few of those resources in mind. But so I'll think on if there's any helpful resources that I use for that and add those. But yeah, sometimes it's just a terrible process of, finicking with those.
Yeah, it looks like that might be all of the questions for this evening, unless somebody sneaks in under the wire.
Well, yeah, if any other questions come up to you, feel free to connect with me again on any of the ways that I mentioned, either on Twitter or LinkedIn or just a comment in the meetup too. I'm happy to answer any questions that may come to you down the road.
Wonderful. And with that, barring any other questions, in which case I'll cut off what I'm saying in my conclusion, but we are going to wrap up this evening for TriPass's data science group. So this upcoming Monday, because it is Labor Day, we will not have Shop Talk. We will have Shop Talk again the following Monday. And stay tuned for different meetups for what's coming in September. And I'm awaiting a question that is coming in with bated breath. 100% baited. So will the video be available to be watched later? Yes, all of our videos are posted on YouTube. If you scroll down a little bit on the page, you should see a link to our TriPass video listing in YouTube. And if you don't see that, I will include it in a comment on tonight's meetup as well, just so that it's obvious where it's at. But all videos go up. They usually go up about 1 to 2 days later and will be available. And with that, we are going to call it a close this evening. Thank you, everybody, for tuning in, and we'll catch you again in the next episode.